So yes, so my name is Julien Thomas, and today I will present a subject called limitations of Android permission system, packages, processes, and user privacy. So I think just a precision, by limitation, I didn't want to say vulnerability or whatever. I will let you judge, is it a vulnerability or not? So that's why we use limitations, so to let kind of you get your own vision of that. So this work is made under the Protectoid project that we started in the company nearly 2 years ago. And if you're more interested about the project Protectoid, I'm very happy to talk about that one too. So the presentation will be quite structured in 6 parts, or a quick introduction to remind very briefly what's permission, how it works, and we'll end that with a demo, if everything is okay. And then I will go more into details about 3 subjects, which is our vision of how permission can be modeled, and then what can we deduce from that in terms of the limitation of the algorithm that implement this model, and in more general way, what's the limitation of this UID-based security that is implemented in Android for user privacy mainly. In the 5th step, I will present an analysis, so the feedback we got from Google, the feedback from the market, and other software that exists, and I will finish with the conclusion. So first of all, the objective of this talk, because I think it's always very important to explain why do we talk. So the objective is to explain, obviously, how permission works and are implemented on Android, because I think it's a very interesting subject. It's also to explain where vulnerability was found, so what kind of vulnerability and where was it found. Because when we explain that, well, it's also leave the audience with something after the talk, which is what can they do to extend the presented subject. So we'll obviously also illustrate the limitation of the UID-based security model in Android. One note that's very important is that we stick in the presentation to what was flagged by Google as overdue or working as intended or fixed. All the others that are still pending, we will not get into details for quite obvious reasons. Another note, so as I said, it was on the Protectoid project that we made this study. And just like to explain where all that study come from, well, it was just like not security at all problem. It was like we wanted to provide a VPN at the software level of the project, and we get a very big problem, which was the undisability to say which application wants to connect to internet when one knows that a UID wants to connect to internet. So based on this undisability, we decided it would be good to understand why we cannot say which application, and then we did this from the UID and all the security limitation of the algorithm on Android. So that was for the objective. So a very brief introduction about permission on Android. So a very important thing is what you had before and after Marshmallow, because Marshmallow, we start to have what we call the dangerous permission, which are now requested to the user. So the user have to approve an application, for example, to access your contact, to access your calendar before it was done at install. So you had the paradigm before, which was when installing apps, the app has all the permission it requested. And now, well, that's not the case anymore. So you have, let's say, 3 or 4 level of permissions. You have the normal permissions, which are granted on install, so that still remain. Then you have dangerous permissions, which are granted on user request only. So normally it's impossible to get a dangerous permission, such as contact, without the user consent. Well, we'll see that. And then you have signature permissions that are granted on a very specific condition that the signature match. So it's kind of a normal permission because it's granted on install, but on the conditions that the signature of the application will request the permission is the same as the one who defined it. So it's, for example, used on system level. For people who already know Android model and the security, so this talk will involve the concept of shared user ID. So it's already known, I mean, like it's not new. So the concept is just to say that if I put here, yeah, you have this shared user ID, which says that, okay, so this application, we share the ID with other applications that define the same user ID. So it's a very well-known issue that sometimes for the system, you could do the same. So we'll not talk about this well-known issue, but we'll talk how we can use the shared user ID to make new attack or exploit new limitations. We will not talk neither about the concept of first one in wins, meaning that before Marshmallow, and that's why we'll also stick to Marshmallow, is that before Marshmallow, well, you could say that if you define the permission first, you own it. If another application tries to define it, well, she will not own it, but she will not know it. She will think that she knows it, she owns it. So you have this kind of conflict that, for example, if you were the first to put on the system an application that define banking permission or whatever, whereas banking application will still install, and she will not own its own permission, and the malware could basically grant itself the permission to access the banking services. So that's been solved in Lollipop. So, as I said, we'll talk about all of that, but in a new way. And a quick demo just to illustrate what I mean by limitation. So what I will just do is I will pop up on the screen my Android phone. Sometimes you just have to wait a few seconds, and I hope it will take 2 seconds. Yes. So, okay. So here we are. So what I will do, that's better. So I will just install application, and we'll see what the result is. So I will start first an application that requests nothing. So just to precise, this phone is running on Nougat, so it follows the same rule as Marshmallow. About the permission. So just a very quick explanation about this screen. So what we see is that we can try to request permission, and at the top we have 2 things very important. It's green on this on the screen. The green zone says what we can say that the application have. And if I click on check system permission, I will say that this application basically requested nothing. We cannot see because that's basically it means request nothing. If we go here, but it's gray, so it's not visible. So I will just now install, because I can, I will install other application. So we'll install 2 applications. Here again, I will explain later that we install multiple applications just for the sake of the demo, but you don't have to install that many. You can just install one and update it, and it still works. So I will install an application that requests nothing. Okay. I will install a second one that requests nothing neither. And now the trick is to update these applications. So I will update the first application after we have a lag, so I will wait. Yeah. So we'll update the first application. As we can see, it requests still nothing. And I will open it. So what we can see here is that it requests internet, but that's a normal permission, so it's granted an install, and it defines its own permission because we can do that. So it defines permission called deadly activity 1. Okay. So I will now do the same thing with second application. I will install it too. The update, it's requested nothing. And I will open it. So what we can see is that she okay, so basically it does the same thing, but I don't know why the screen is locked, like for the demo, just at the end. So I will restart the screen. So basically this app does the same thing, just define its own permission called deadly activity 2. Okay, so I just close all the application, and now I will open the first one. So, which is the application that define nothing, requesting nothing. Okay, so as we see, we open it again. It's on the green zone, we have nothing displayed. If we try to see the permission on the system layer, it's still gray, meaning while it has nothing, it got granted nothing. So now what we will do is that we try to access user contact. Well, normally this would have crashed because we don't define the permission and we did not request it as the user, so 2 reasons to fail. Well, we see that we can access contact. Like we have one contact because it's a demo phone. I will do the same thing with calendar. Well, it's the same thing. we didn't define the permission on the manifest of the application. We did not have the user to approve to give us access to calendar. The system says that we don't request anything, we are granting nothing. The API level, which I will explain also later, says nothing, while we can access everything. So the goal of this presentation is to say how is that possible in Marshmallow and Plus to have that. I mean, like, if someone wants me to re-explain, because I think it's very important to understand like what's the implication of that. So it's clear for everyone? If you have a question, we can still later. So, modeling of the permission. So if we talk first about, like I was saying, I want to talk about user privacy. So one thing very important is resources. I mean, like we protect resources. So on Linux, because Android is based on Linux, so we have two concepts, UID and GID. On Android, that's set by the Zygote, which fork an application to create the process. So an application cannot create its own process. That's a manager called the Zygote that does that. And it does two things. When you install an application, its UID is defined, set, and cannot be changed. And when you launch the application, well, it gets granted group IDs based on the permission it has. Generally, UID is made for protecting files. So the application directory is protected on the user ID of the application. And the external directory is protected on the user ID and the group ID called SD card read write. When you talk about GID, so for resources that are not files, you have the, for example, you have the protection for the network access. So what we have in Android is called the paranoid networking, which states on the code that you have to have the good groups. And on the software level API, well, you have what we call service-based EPC preconditioning, which means that if you want to make an EPC call to a service, it will check that you are granted the correct groups or the correct permissions. So if we summarize very quickly, what does that mean? Is that here we have the local file system that is protected by UID level. Here you have what we call the services that are called through EPCs that can access resources through permission conditioning, so that's implemented by the services, or by a group, so that's implemented at the kernel level. So that was for how resources are, let's say, protected in a very general way. So now the question is like, okay, so we have permission that we define as manifest. Well, what does that mean? How does that work? So when you have an application, you define, you call permission, I mean, you define that you want to use permission by the tag called permission uses that says that you want to use either system permissions or other app permissions that are already there. You can also define your own permissions, as I showed in the demo, and you can put them in whatever you want, wherever you want, the way you want. So we are very free on that. So when you install an application, what happens is that based on the condition of the manifest, the app will be set a UID. So that's what we call about the security of the local file system. You will allow custom permissions that are normal, I mean, that are, yes, normal. And you will stock all of that in a raw-written way on what we call the package with an s.xml that define all the application installed on the software, I mean, on the device. When you have the system permissions, they are predefined, so it will depend on the manufacturer. But if we just stick to the Android open source project, you have main permissions such as internet that are associated to group ID. So all of that is predefined when you have your device shipped to you. And basically what happens is that when you launch an application, well, based on the definition you had at install, you will get a UID. And then the Zygote will use all of that together to grant the GIDs and the permissions. So basically, that's the model. And what we can see here is that we start to have something complicated, is that it would be easy if we have one application that uses system permission that is granted that process. But because of the shared user ID, you can have multiple applications that somehow interoperate together and use system permission together because they share the same user ID and are granted permission. So here it starts to be much more complex than a simple application at install or at launch get granted something. Like it's like you have to first work on the on the cooperation between the definition of multiple applications. And we will see that's not that easy. Another important thing to know where the vulnerability will come from is that when you launch the system, everything starts to be built up. So we have what we call the package manager service that just load everything into memory. And at app launch, well, basically you use what is predefined in the memory to assign to the process. So obviously, if you preload on memory everything at system load for performance reasons, well, you have to be safe about how you handle the evolution of the model. Meaning when you update an application, when you remove an application, you have to be sure that the package manager service updates the model in memory accordingly. And one of the questions we have there is that, is it sand? Meaning like, compared to reboot a device or compared to install an application with a new version, so without the update path, is it the same thing as keeping your device powered up and updating an application? As we'll see, the answer is no. Another thing very important is that, as said before and after Marshmallow, I mean, like, for everybody who would build software, you know that you have a very problematic solution when you make a very big update on a software definition, which we call the backward compatibility, which means that you have to be able to still make old application works with the old security model, while the new applications that relies on Marshmallow API, well, are not granted by default permissions that are dangerous. And this means a lot of implications. Like you have to update the algorithm correctly. When you display to the user, you have to take into account, is this application an old application or a new application? And the question is like, what happened with a single user ID, you have two applications that do not follow the same API level. You have an application that is supposed to be granted everything by default, and an application that is supposed to be granted only normal permission by default. But they are on the same user ID, so they are granted the same permission. So there's a question here again. How do we handle that? I mean, like, what's the vision of Android compared to a strong security, which is you have to ask the user, and a weaker one, which is everything is granted and installed? And one of the interesting feedback we got from Google, and I will let you judge, is that they say, well, no, we show them that it's not sent, but they say, look, yes, but we never promised. I will explain that. So that's a very broad model here again, is that so when you launch a system, everything is granted, you have the memory, and the user action, install updates or grant permissions, impact another service, and all of that cooperate together. Finally, last part of the models, and I will go more deeper into the vulnerability limitation explanation. Okay, so we know how it's defined. We know how it's computed. Well, the other question is how it's displayed to the user. So we have what we call the system info. So basically, it displays package permission based on package information. Okay? And the other very important thing is that it displays status. Well, not from the package info, but directly from the system, because the system info so it access to the system allocated memory. You have another level of display which is used by any security application, which is what we can call the API of the package manager, which display package permission here the same way as above, so based on the package info. But as this is an API that is run at the application level, it doesn't have access to the system memory. So it has to use another way to access the permission, so it's not 100% the same thing. Here's a very big model. I mean, I will explain more step by step. So here we have the memory, the definition. Here we have the display. Here we have word that impact. And here we have some kind of the memory logic. So we see that's not that easy, but it's good because it's not easy, which means that it's likely that you have things to do on that. So, subject. That's basically the limitation I will present. I will just go back to that after. Basically, on the system, on the model I explained, I try to put some colors to say the where is good, where is not good, where is debatable. So green is good. Pink, that's not really pink here. Pink is debatable, and red is bad. So we see that we have quite a lot of places and a lot of things that we can play with. And this is interesting. So, issues. I will explain 4 issues. How can you hide permissions from Android? meaning like you get granted permission, but you don't display that because it's cool. How can you hide states? How can you say that a permission is not granted, that it's granted? Nobody knows that you have contact. You see that the application request is contact. It says not granted, yet it's granted. I mean, like, why is that possible? How to keep unrequested permission? You didn't request a permission, you are granted by another application, you remove the other application while you still have it. Well, you can do that too. And I think the last part, which I will less explain because it's still not passed by Google, is that how you can auto-grant dangerous permissions such as contact. So basically, that's what I showed in the demo at the end. So first, how can you hide permission from Android? As I said before, when you go to the system information, you display the permissions that are defined on the package info, meaning you put on your manifest that you want to access contact. Even if you are granting something else, it will never be shown because the display relies on what you ask, on what you define. So the thing is how you can make the system grant you something that you did not request and that will be never shown to the user at any level. I put some source code very quickly. And basically, what does it say is that on the left, we have what we had on Marshmallow, and on the right, we have what we had on KitKat. I mean, KitKat was fine, it displayed everything, not Marshmallow. And the big issue is that on Marshmallow, we stick to, we'll just be sure, yeah, we stick to the package definition. On KitKat, we say, oh, okay, so we have our own definition, we may have a shared user ID, let's get all the packages that share the same user ID, then federate that together and display. Well, in Marshmallow, they decided, well, no, we don't want to do that anymore. We just want to display what we asked. Well, it means that if you use a shared ID concept, another application we have for contact, by user ID that is shared, you will access contact to, but it will never be displayed because of the decision to stick to the package definition. So as I said on the demo, basically you just have to install 2 applications, and they will share everything. One of the feedback from Google from that is that it says it's not a security issue and an intended behavior because everybody should know that you can share permission across application. Okay. I promise I will not make any comments. I'll just let you make your own decision on that. So another interesting thing is how can you make an application flag that's not enabled yet enabled? So here that's a little more complex because we talk about backward compatibility with app-op concept in KitKat. Meaning that here, when you revoke a permission, this try to start to deal with, so is it a new application? Is it an old application? If it's an old application, do you have app-op? I mean, you see the logic is very complicated. And what we have here is that basically, on this very specific case, which is like if you are not a new application, so you follow the old model of KitKat, well, you will try to update the app-op. Okay, I mean, that works before. But basically, they just didn't say that we will not grant the permission anymore. So basically, the permission is still here. It's still granted. But only the app-op flag, which worked before, is set as denied. Okay, so what does it mean? I mean, it's not that easy to understand the consequences because it's kind of weird behavior in the end. Because basically what you can do is that you can install 2 apps, one made for KitKat, one made for Marshmallow, and grant concat from KitKat. And what will happen is that here, we have a lot of very weird results. If you stick to contact, well, the application on Marshmallow will say that it has contact access, but when you try to access contact, it will say 0, no matter how many you have. If you try to access from the KitKat application, it will say denied, and it will say 0, so that's normal behavior. But the interesting stuff that we in fact discovered yesterday, which is what happens if in fact it's not a system permission. Well, if it's not a system permission, you have much more underneath logic of the app-op concept, which says that basically they don't have app-op mapping, so they will do nothing. So we'll say and grant, and will still be here. So which means that in fact, the system will believe it's not granted, but it's still granted, and you cannot prevent that. Okay, so another issue, which is how to keep an unrequested permission even after the permission on application, I mean the application we defined it is removed. So here again, we have what happens if we have 2 applications on Marshmallow, here we don't care about the API compatibility, that says that they want to access internet, Bluetooth, and contact and calendar. So here I put a source code, then I will explain the case. That here we have an interesting thing which says, so this routine is called, the update shared user permission. So basically the app knows that it's a shared permission, so we try to correctly remove the permission from other applications that share the same user ID. And we have something very interesting. When you look here, it's a very big loop. So basically, we try to get all the permissions that the application that is going to be removed requested. And we will see, do other application required it or not? If we do not require it, well, normally, we will remove the permission from the user ID set. But we have one issue, which is what happens when we have group ID. For example, when you require internet or you require Bluetooth, you have group IDs at the process level. And when you do not request internet anymore, when nobody requests internet, the group ID has to be removed from the process. Otherwise, you can directly physically access at the kernel level because you will be granted the correct groups. So what they say, I mean, the logic here is good, just the implementation is not. It says, okay, so if you do not access a permission that requires a group, well, exit and then grant the group. Well, that's good. The only issue is that you should not exit. I mean, like, you should flag the fact that you need to reboot the application, all the application of the shared user ID after you removed all the permission to have the group ID correctly mapped. But if you stop at the middle of the loop, well, what will happen is that the first time you see a permission that requests a reboot of all the application because of that, well, it stops here. All the other permissions that should have been removed are still here. So an example, so I said here, install a KitKat application. That way we don't have to do anything. You install a KitKat application, everything is granted by default. So you have for Bluetooth, internet, contact, calendar. And then you install another application that has nothing. And you remove KitKat. But what will happen is that depending on how the order you define, so if you define Bluetooth first, well, the package manager will see that Bluetooth is not requested anymore. It will stop. It will remove, after having removed the Bluetooth permission, it will stop. It will ask all the other permissions of the other, applications or processes that share the same user ID to restart. But all the other permissions, such as internet, contact, and calendar, will be kept. Which means that the other application will have nothing, now is capable of sending contact and calendar to internet, while normally it should not have at all. So that one is under review. And the next part, which I said I will not go into details because I think it's too much sensitive, because it's very easy to do, which deals with the concept of how the update of a permission definition is handled on the Android level. Meaning, what's the difference between granting a permission to an application and then updating the definition of this permission, compared to grant a permission with the latest version of this definition? It's not the same, unfortunately, and it means that if you define correctly the good permission, if you define the good way the permission, it will not be requested anything, and if you update it, well, it will have contact or whatever you want. It will get contact without asking you. So just to say the truth, we reported this bug 2 months after the first one. We reported that, but like it was 8 months ago and still not patched. Okay, so we're not going into details of others because you can do quite a lot of things. How you can keep permission on upgrade, how you can prevent how can you prevent permission from being ungranted? Like the user says ungrant, he thinks he's ungranted, but still here. You have quite a few stuff like that you can do, and you can do also very not useful, so useless ones, such as how can you prevent someone from granting you permission? You can do that. So that's quite interesting. I will just take the time, 10 minutes, that'll be fine. So the other thing important is, like I explained very deeply, is the limitation of the algorithm about permission implementation. So okay, so now we see if we can grant permissions and we can do stuff. But the other subject I think in Android that is not well enough debated is like the implication of the UID-based model in general on Android and what it means for user privacy and how the files are really protected on the system. So what kind of limitation I want to talk about here? I don't want to talk about the UID versus lattice force model, so it's not a general presentation about airbag versus DAG versus whatever. It's much more about like how can you trick the user because the user don't know anything about like what's the consequences of UID, what does that mean, like it knows nothing. I mean like even the policy of Google is that the user should know nothing and everything should work fine. So how can you trick the user so that in fact he doesn't know what he's doing, he thinks everything is safe because he trusts Google, well he should not. So that's the kind of limitation I want to talk about. And three example, which is how can you bypass the concept of jail by shared UID? How can you bypass the concept of UID security by in-app virtualization and app security by in-app virtualization? So what UID is, in fact, like, it's a very complicated subject on Android because UID is not associated to an app because shared UID. It's not associated to publisher key because you may have multiple applications made by the same developers that don't have the same UID. I mean, if they don't have the same shared user ID, each application has its own UID. But the set of application, but I mean, like the set of UID is included within the set of applications. So it's kind of a mix between like a set of UID belongs to a publisher and only a publisher, but it's not per application. Meaning like, if you grant a permission to an app, well, you don't grant a permission to an app, you grant a permission to a UID. But you don't know if this grant is to an app or to a set on the app. And that's impossible to know without any security application because Google do not show you that. And it's by design. I mean, the thing is very important is that by design they decided to do that. And by design, you also have permissions that are not displayed. You have system applications that do not show that they has contact, yet they has contact. So you can have a set of a configuration when nobody knows that contact has yet is shared. So like this concept of UID doesn't make any sense really when you have this kind of shared UID and choice to hide stuff. And then when you want to go to external storage definition, that's even worse because you have UID on the external storage, but it's more controlled by remote services, so the UID doesn't make any sense neither. So like it's very not clear for the user what the consequences of security of the file system on Android. So that was like a very quick apartheid about like the UID definition limitation because of this whole decision and shared UID. Another thing very interesting is what we call in-app virtualization. So I flagged something at pre-virtualization, which was what we had before, which is what we call dynamically loaded executable code. So the goal for that was to hide automated analysis, to make the code like the malware payload encrypted and whatever. And then, so that was Julien. And then now you have quite very stable open source libraries that allows you to do what we call in-app virtualization, meaning like you have an app that powers within the app a virtualized Android system that in which you can run, but like really run other applications. So it's a lot of very good features, but it's kind of here again. The users don't know that. I mean, like the user will never know that if we install a game, it has the capacity to open Facebook within the game and control the game. I mean, like before you can load code, but you cannot load application. So now you can have very interesting attacks, and we see that with plugin Phantom and Embed. Basically, what they do is that they load app within their own environment, and they can control it. And by that, you can do quite a lot of very good stuff, because as you share the same UID, I mean, as everything is the same process, it's very hard to detect. Because if you have a very good virtualization implementation, even projects such as the anti-plugin project are limited. Because if you make the application that is virtualized, so hosted, not capable of detecting that she is virtualized, well, she cannot know. But what she will know is that, what she will not know is that the data she has is owned by the host. And I will show that later. And as I said, right now it's poorly implemented, but it's already there. It's poorly implemented because it's not really stable. And we can do a lot of other stuff that's not seen yet on the market, which is memory structure rewrite. So a very quick question that I had thanks to a talk at another security conference, which is, who knows the concept of multi-space? Like parallel apps and all these concepts that allows you to run multiple Facebook instances on the same device. And who use that? I mean, like, you should not. Because, well, I mean, like, a lot of users did. I mean, like, I want to mention user misjudgment. Nobody knows the consequences of using parallel space and other apps. But what you have here is that here, when you try to grab the Facebook concept, I mean, you will see that Facebook is run by two different UID. That's the normal UID, which is A113. But the host, which is the ID 146, also runs Facebook within its own ID, so its own process. So it controls it. When you talk about files, that's the same thing. That's the expected location of Facebook data. And on the virtualizer, it's stored on the virtualizer data, meaning the virtualizer can access all the data that Facebook stores. Contact database, everything is owned and accessed without any request by the host. So I will go very quickly on that because I really want to finish the other stuff in 5 minutes. So question was the impact of new security mechanism on Android. So I don't know if you have heard about Play Protect and Treble. I think it would be very hard for Play Protect to detect advanced virtualization capabilities because, like, it's not hidden behavior, that's expected behavior. The goal of Play Protect is to detect bad behavior. But if your app is defined as a virtualizer, well, it's not bad. Just nobody understands what does it mean. I mean, like, no user understands the consequences of that. And with Treble, here again, what's the impact? It would be a very good question to see in the future. So I will just go very quickly. Here, that's all the bugs we submitted to Google. So we had one working as intended, so we decided to split it in 13. And now we're discussing with Google, it's much more interesting than only one. We made run on multiple apps. And what we can see is that on the market, everybody is nearly fine. Like, nobody is exploiting anything. When you compare to various databases, nobody is trying to do this kind of advanced algorithm checks. And the question is, what will happen when we start to have that? I mean, like, Android is already known for malware, but it's kind of, let's say, malware that has permission. Well, I mean, they can allow to not even ask. So what will happen when we start to have that? When we try to compare security apps that exist on the market, I will say that even the security apps do not take that into account. They will sometimes, some of them will display the status of the permission, but not all of them. So basically, we not know if an application access contact or not, because the app says, yes, it defined it, but you don't know if it asked or not. You don't know if it's granted or not. So like here again, the security apps have a lot to do to be able to cope with this new implication of Marshmallow plus permission model. And a very quick conclusion, I think I'm on time. Even if I criticize a lot the limitation of the model, I mean, like, one thing to know is that basically I was talking about the limitation of the update path. But like, you have all the underneath security, which is like the permission protection that EPC called, which is very robust and very well implemented. I mean, like, we spent months trying to see where we could do stuff, and it's like, it's very hard to hack. And rebooting the device fix the problem, but like, what's the odds that you will reboot the device after each application install or update? I don't know. Security applications are still needed, I believe, because Play, Protect, and Treble projects are good, but do not cope with some limitation, and will not, because that's not the goal. And what's important is that the security applications should really focus on what they do. Meaning they provide security, they don't provide display to the user, so they should understand that, in fact, what does the display things correctly or not? Much more work to do here about, like, not only using Android package manager function, but also understand the application of that. Would be very good to have better security solution. And obviously, we have a lot of new challenges, like instant apps, projects that started to be available to developer, Treble, as I mentioned, virtualization capability, which means that we still have a lot of things to see in the future. And thank you for listening to me. If you have any question, I'm free after also too.